Hello everyone, welcome back to my channel Shubhangi Insights. So today we will be doing the third topic of measures of central tendency, which is mean deviation. Now, as we have already seen in the other two videos about the other two topics, range and quartile deviation, whenever you see the formula there will be a difference between them, subtraction, right? Same thing you will be seeing in mean deviation also. First, let us understand what is mean deviation. It is the mean of the absolute deviations of a set of observations from any measure of central tendency. It is denoted by MD. So, let us see what have they defined and what have they given us in the formula. So, again we will have the formula for three sets of data: raw data, discrete data and continuous data, and then we will see the coefficient of mean deviation also. Now, when we are talking about raw data, let's compare the definition and the formula. They have told us it is the mean of absolute deviations. So here they have mentioned as absolute deviation. What do we understand by that? In case if your difference is negative, even that will become positive by applying the mod. That is only your absolute deviation. So here you can see in the formula we have applied this absolute deviation, absolute symbols, two lines, which makes your negative term also positive. In all the formulas you can see that we have applied the absolute mark. Now, absolute deviations of set of observations from any measure of central tendency. Now, set of observations means your x value. These are the different values given to you in the question, your x values, and that taking the difference from any measure of central tendency. Now, as we have already seen, central tendency means mean, median, mode. So, if you take the difference of a set of observation from any of these three, either mean, median or mode, you will get your formula for mean deviation. Here I have considered mean deviation from mean. So, subtracting the observation with the mean, you get your mean deviation from the mean. Subtracting your observations from the median, you get your mean deviation from median. Subtracting set of observations from mode, you get mean deviation from mode. And this you are dividing by small n, which is your number of observation. If you look back to your formula for arithmetic mean, it was summation x by n, right? Sum of observations by total number of observation. It is very similar to that only, but here you are subtracting the observations with any measure of central tendency and then dividing by n. So this is for your raw data. Now, when you come to discrete or continuous data, it will remain same for both the cases. Here what happens, along with your x column, you have a frequency attached to it. So that's the reason we have frequency in the formula. So mean deviation from the mean is equal to summation f into x minus x bar. Again we have taken the mod and we have taken the set of observation from your mean divided by total number of frequency. Similarly, mean deviation from median is summation f x minus m by summation f. Mean deviation mode from mode is summation f x minus z by summation f. So these are the formulas. Either you can apply for discrete data or continuous data, it remains the same. Now coming to the last one, what are the coefficients of mean deviation? These are your relative measures. Now, coefficient of mean deviation from mean will be mean deviation of mean by mean. Now, in case they'll ask you calculate your mean deviation from maybe mean, median, mode, and also find out the coefficient of that. Now, once you calculate your mean deviation, maybe for your raw data, discrete or continuous, you can take the same value and substitute it here and divide it by mean. Obviously, you will be finding your mean also, so that value will be divided. So this is how you will get your coefficient of mean deviation. Similarly, coefficient of mean deviation from median will be mean deviation of median divided by median. Coefficient of mean deviation from mode will be mean deviation of mode by mode. So let us look at the problems, then it might be more clear to you how each question are done. Let us look at the first question. Calculate mean deviation from mean and its coefficient for the following data. This is the data given to us. Now, whatever data is given to you, you're supposed to write that particular data in your answer. Now, before that, we need to understand which kind of data is given to you from the three types of data which we have seen. Either it has to be raw data, discrete data or continuous data. If only X values are given to you, that becomes your raw or ungrouped data. If X value along with frequency is given to you, that becomes your discrete data. If class interval along with frequency is given to you, that becomes your continuous data. This is very important to know which kind of data is given to you. I think in the previous videos also, when we started out with arithmetic mean, I started explaining from there onwards that please check your data and apply the formula accordingly. Now here let us take up all these values under your X column. So the values are 100, 150, 200, 360, 490, 500 and 600. These are your X values. Now I have written down my X values. Now which column to be done next? So that is done with the help of formula. Now first of all, they are asked us to find mean deviation from mean and its coefficient, and your data here is raw data. So first write down which kind of data is given to you. So this is a raw data. Now mean deviation from mean for raw data will be summation x minus x bar upon n. Okay. Now for calculating x minus x bar, first we need to find out the value of x bar. For x bar means your mean. Now what is the mean for raw data? It is nothing but summation x upon n. So first you have to take the total of x column and divide it by small n. Small n is nothing but a number of observations given to you in the question. So the total of x column is 2400 divided by number of observation 1, 2, 3, 4, 5, 6, 7. So that we will divide by 7 and answer is 342.86. This is the value of x bar. Now we will take this x bar in this particular formula and substitute and all the observations subtracted from this mean. So let's do that. X minus x bar modulus. When you apply modulus, even if you have a negative term, that also becomes positive. Now first value is 100. So 100 minus your mean is 342.86. So after subtracting, we will be getting 242.86. So this is how you will be getting all the answers. Since it was negative, but because of modulus sign, that has turned positive. Now let's find out the rest of the values. So your rest of the values are 192.86, 142.86, 17.14, 147.14, 157.14 and 257.14. Now we also need to take the total of these particular columns. So that is 1157.14. Now let's substitute this particular value in the formula. So which is mean deviation of mean is equal to 1157.14 and your n value is 7. So dividing it by 7, we are going to get. Okay. So here after calculating your mean, we will substitute the mean deviation from mean formula. The total of summation x minus x bar is 1157.14 divided by 7 and the answer for this we will get 165.31. It is mean deviation of mean divided by mean. It's better practice to always write down the formula first and then do the substitution, because even the formula carries some marks. So here mean deviation of mean is nothing. So your mean deviation is 165.31 and your mean is 342.86. So the final answer is 0.482. So this is the answer. So after substituting, we get the answer for coefficient of mean deviation. So once you read up your question, you need to understand which kind of data is given and which formula are they asking you to substitute. Let us look at the second question. Calculate mean deviation from mode and its coefficient for the following data regarding marks of 10 students out of 25. So they have given us marks of 10 students in this particular way and they are asking us to calculate mean deviation from mode. as well as its coefficient. Now first we need to guess which kind of data is this. Since only x value is given to us, so obviously it is a raw data. So the formula for raw data of mean deviation from mode will be summation x minus mode by small n. For that we need to calculate the mode value for the given data. So first let us write down the x values, the set of observations given to us: 7, 4, 10, 9, 15, 12, 7, 9, 7 and 18. Okay. Now how are we supposed to calculate mode for raw data? Mode means the highest repeating value. Now which value is repeating many number of times? 7, 7, 7. 7 is repeating 3 times, so answer is 7. Most repeating value. So we have already calculated the mode. It is very simple in case of raw data. Now we just need to substitute that in the formula. So that is x minus 7. So first value will be 7 minus 7, which is again 0. 4 minus 7, which is 3. 10 minus 7, 3. 9 minus 7, 2. 15 minus 7, 8. 5, 0, 2, 0, 11. And then we need to take the total of this particular column, which answer is 34. Now we will substitute back here in the formula of mean deviation from mode, which is 34 and observations is 10. Answer is 3.4. Now we also need to find the coefficient. So we'll write down that coefficient of mean deviation from mode is equal to mean deviation of mode by mode. So mean deviation of mode is 3.4 and the mode value was 7. So the answer after calculating we are going to get 0.48. So this is the answer for your mean deviation from mode in case of raw data. Let us see the next question. Find mean deviation from mean for the following data. Again they are asking us to find mean deviation from the mean, but the data is different this time. Here we have x values given to us, x column, and we have frequencies, number of persons given to us. So when we have x along with it, that is called as discrete data. Now the formula for discrete data will be mean deviation of mean is equal to summation f into x minus x bar divided by summation f. So here first we need to find out x bar, then we will subtract it with x and then multiply with f. So first let us find out x bar in case of discrete data, which is summation fx by summation f. So we need to multiply f into x and then we have to take the total of f column. So let us make another column x into f and write down the answers for this, which is 120, 61, 868, 1827, 1600, 780, 660, 268 and 136. So we need to take the total of this particular column also, which is 6320, as well as total of f, which is 100. So let's substitute that in the formula. 6320 divided by 100 and the answer for this is 63.20. So we have got our mean. Now we have to substitute back in this formula in order to get our mean deviation from mean. So let us make the column f into x minus, the mean is 63.2. So we have to consider f column and then multiply that with x minus this. So for in case the first one is 2, x is 60 minus 63.2 will give us the value as 6.4. 6.4. Similarly, the rest will be 2.2, 16.8, 5.8, 20, 21.6, 28, 15.2 and 9.6. Now let us take the total of this particular column, which is 125.6. Okay. After finding out this column, we are going to substitute back in the formula, which is mean deviation of mean. So here the mean deviation from mean 125.6 and the mean is 100 and the answer is 1.256. So this is how we calculate the mean deviation from mean. Let us look at the next question. Calculate coefficient of mean deviation from median for the following data. So first let us understand which kind of data is given to us. X column along with F column. So this is nothing but discrete data. Now let us write down the formula for that. Mean deviation from median. So M, and since it is discrete data, so frequency will be attached. X minus M along with summation F. Now let us find out the median first in case of discrete data. So the formula for median will be n plus 1 by 2th observation. Now in order to get n plus 1, capital N is nothing but your sum of frequency. So first let us take the total of frequency. So total of frequency is nothing but 49. So let us substitute here 49 plus 1 by 2th observation, which is 25th observation. Now we need to find out this 25th observation in our data. Since we can see that in frequency it's not possible to find out because these are nothing but your random numbers. But what if we find out cumulative frequency, addition of frequency, then it will be easy for us to find out this 25th observation, right? So let us calculate the column of LCF. First value will be same as your frequency, which is 8. Next you have to keep on adding it, which is 20, 8, 38, 38, 46, 48 and again it is 49. So let us look at this particular value. 25th will lie between 20 and 38, but the highest is 38. So this will become your median class. Median class. Now the respective value for this median is 7. So your median will be 7. Now let us substitute this in the data and get this total of this particular numerator. So let us write down that also. Frequency into x minus 7. So frequency is 8, x is 5 minus 7. So which is going to be 8 into 2, 16. Since it is negative, because of modulus, it's going to become positive. Now let us write down the rest of the values also, which is 12, 0, 8, 4 and 3. And let's take the total because we need the summation of this, which is again 43. Now let us write down in the formula. Mean deviation of median is equal to 43 upon total of frequency was 49. So the answer for this is 0.878. But in the question they have asked us to calculate coefficient of mean deviation. So because for coefficient of mean deviation also we require mean deviation, that's the reason we found the mean deviation. Now we'll substitute that in the formula. Coefficient of mean deviation from median is equal to mean deviation from median divided by median. Now what is the mean deviation from median? It is 0.878 and the median was 7. So the answer is 0.125. So this is how we will be calculating mean deviation from median in case of discrete. See the next question. Compute mean deviation from mode for the data given below. Now let us understand which data is given to us, x along with f. So this is nothing but your discrete data. So let us write down that. The formula for mean deviation from mode in case of discrete data will be summation f x minus mode by summation of f. So in order to get the answer, we have to calculate the mode value first. So the mode will be value of x corresponding to highest frequency. We have already calculated the values of mode in case of raw discrete continuous in the previous videos. You can go and check out again in case if you're not understanding this. Now here the z is nothing but value of x corresponding to highest frequency for your raw data. Now what is the highest frequency? It is 35 and the corresponding value is 2. So the answer for the mode will be 2. Now let us substitute this in the formula and get the rest of the answers. So here it is frequency into x minus 2. So frequency is 18, x is 0 minus 2. So which is equal to 36 in the first case. Now let me write down the rest of the values. You can calculate yourself and check whether these values are matching to the answer. 22, 0, 25, 40, 36 and 8. Now we need to take the total of this particular column, which is 167, and divided by total of frequency, which is 134. Let us substitute now. Mean deviation of mode is equal to 167 by 134, and the answer for this is 1.246. 1.246. So this is the answer we get for mean deviation from mode in case of discrete.